So here we have question number 1.17 and the question says कि the vapor pressure of water is 12.3 kilopascal at 300 Kelvin. Calculate the vapor pressure of 1 molar solution of non-volatile solute present in it. Right. So at 300 Kelvin, the vapor pressure of water is 12.3 kilopascal that is given. We have to calculate the vapor pressure of the solution, whole solution of 1 molar contain non-volatile solute in it. Simple. So let's see that what it question says. Once you will understand the scenario, then you can easily calculate all this the thing that is that question is asking to calculate. So this is my solution, and this solution contains non-volatile solute, right, and plus water. Simple. And as we know by Raoult's law कि whatever component that is present, it will exert partial pressure that is equal to mole of that component present in liquid phase into that vapor pressure of that particular component. Simple. At the temperature, at constant temperature, T is equal to 300 Kelvin. Simple. That is it. That's it. Now P2, that is the partial pressure due to the component 2, is also equal to I have to use equal to because I am writing the P1 sat also, so it is equal to, so P2 is equal to x2, that is mole fraction of that particular component in liquid phase into vapor pressure of that component at that particular temperature, right? So this is it. Now what happens when you take non-volatile solute in the solution? What happens is, suppose this is partial pressure, this is the vapor pressure that is exerted by second component, and suppose this is non-volatile solute is the second component. So the partial pressure that is going to, because of this non-volatile solvent, is 0. Why? Because that non-volatile solvent is not going to vaporize. It is non-volatile, right? So वो component जो है वो volatile है ही नहीं, वो vaporize हो ही नहीं पाएगा, और अगर vaporize नहीं हो पाएगा तो गैसियस फेज में जा ही नहीं पाएगा, और जब गैसियस फेज में नहीं जा पाएगा तो वो प्रेशर एग्जर्ट ही नहीं कर पाएगा अपने कंटेनर पे, तो इसके कारण कोई पार्शियल वेपर प्रेशर होगा ही नहीं, और जब वेपर प्रेशर जीरो होगा एट एनी टेम्परेचर तो उसका पार्शियल प्रेशर भी जीरो होगा, राइट। तो इसलिए नॉन वोलाटाइल कंपोनेंट के कारण कोई आपका कंट्रीब्यूशन नहीं होता है पार्शियल प्रेशर में, राइट, अंडरस्टैंड। सो आपका क्या होगा कि जो वाटर है दैट इज द ओनली वोलाटाइल कंपोनेंट प्रेजेंट इन दिस सॉल्यूशन इज गोइंग टू कंट्रीब्यूट एज टोटल प्रेशर, सिंपल। So PT is equal to P1 plus P2, partial pressure due to component 1 plus partial pressure due to component 2. So partial pressure due to component 2 because of non-volatile solute is going to be 0, simple. So that's why the partial pressure of component 1 is solely going to contribute for total pressure of that solution, सिंपल। तो वही आपसे पूछा गया है कि वेपर प्रेशर ऑफ द सॉल्यूशन क्या होगा, तो सॉल्यूशन वेपर प्रेशर आपका वही होगा जो पार्शियल प्रेशर ऑफ वाटर होगा, सिंपल। क्यों होगा ऐसा समझ में आया? और इसीलिए हम जैसे ही कैलकुलेट करेंगे पार्शियल प्रेशर ऑफ वाटर, और हम इसी को बोल देंगे आपका, इसी पार्शियल प्रेशर ऑफ वाटर को हम बोल देंगे दैट इज द टोटल प्रेशर और द वेपर प्रेशर ऑफ सॉल्यूशन। तो आप कंफ्यूज मत होइएगा, क्योंकि यही जो पार्शियल प्रेशर ऑफ वाटर है यही सोली रिस्पॉन्सिबल है फॉर द प्रेशर इन दिस सिस्टम, राइट, सिंपल। नाउ लेट्स सी द सॉल्यूशन। सो गिवन दैट सबसे पहले आपको राइट करना है, उसके बाद वेपर प्रेशर ऑफ प्योर वाटर यू हैव गिवन एट 300 केल्विन दैट इज P1 नॉट इज इक्वल टू 12.3 किलो पास्कल and molarity of the solution containing non-volatile P1 not is equal to P1 sat, it is similar. Pressure at saturation is equal to vapor pressure, that is same thing but different name, right? So molality of the solution containing non-volatile solute is 1 mole, right? So 1 mole, what it means, that number of mole of solute by 1 kg of solvent, simple. You have to understand this formula for using this, simple. Number of mole of solute by 1 kg of solvent, you have to remember this, right? Then molar mass of the water is 18 gram per mole, Simple. Now you have to calculate that, as you know that from Raoult's law, P1 is equal to x1 P1 naught. That is, partial pressure of component 1 is equal to mole fraction of component 1 in the solution into vapor pressure of that component 1 as a pure component, right? So after that, you have to calculate the mole of solute. So mole of solute, it is given from the concentration formula, that is mole concentration of the solution is given is 1 molality means 1 mole of solute means 1 mole of non-volatile solvent is present in 1 kg of solute is present in 1 kg of solvent means 1 kg of water, right? So as you know, 1 mole of your solute present in 1 kg of water means 100,000 gram of water, right? So once you know the weight of water, you can calculate the number of mole of water that is present in it. That is 1000 divided by 18 gram per mole. That is 55.56 mole of water present in it. And we are calculating it because all that particular, the only volatile component present in water. And we have to use this in the formula x1 p1 sat. So in this formula, the mole fraction, we have to use it for water because this is solely responsible for the pressure in the system, right? So that's why we are calculating mole fraction of water here. So now after that, mole fraction of water that you have to calculate. So number of moles of water by total moles. So 1 mole plus 55.6 mole of water, mole of water in plus mole of your non-volatile, and then at the numerator mole of water. So this is going to be 0.982 mole of water. Simple. So mole fraction of water, sorry. So once you know the mole fraction of water, you have to put this in the formula, and P1 sat you know for water at 300 Kelvin. So you will calculate the partial pressure due to water, and partial pressure is going to be total pressure of the system because that only volatile component is water. Simple. So calculating the vapor pressure of solution we have. So vapor pressure of solution P1 is equal to x1 p1 sat, that is equal to 0.982 into 12.3. 12.3 is your given in the question, that is 12.3 kilopascal is vapor pressure of water at 300 Kelvin. And after calculating that, you will get P1 is equal to 12.08 kilopascal, and that is going to be total pressure or vapor pressure of solution. Simple. So this is it. This is the thing. You have to just know the simple the concept that non-volatile solute is not going to contribute in partial pressure. So the whole pressure is due to the water here, right?